Hello students, in this lecture we will start with a new chapter which is metals and non-metals. As you know that element is a pure substance which is made up of only one kind of atom. And students, today there are around 118 elements known to us, and if we talk about their classification, these elements are broadly classified into metals and non-metals. So students, this chapter deals with metals and non-metals only. So let us begin with the chapter metals and non-metals. So students, our chapter is metals and non-metals. Metals and non-metals. So students, today we are going to start with a new chapter which is metals and non-metals. First of all students, let us know what are metals. Students, the knowledge of metals is very old. Copper was the first metal known which was utilized in the formation of utensils, weapons and many more things. And moreover students, metals play a significant role in our daily lives also. So students, first of all let us know how to define metals. Metals are the elements which possess luster when freshly cut. These are malleable, these are ductile and these are very good conductors of heat and electricity. So let us define metals. Metals are the elements which possess luster when freshly cut, are malleable and ductile, and students, these are good conductors of heat and electricity. And good conductors of heat and electricity. Or students, we can also define metals as the elements whose atoms can readily lose the electrons, and when these lose electrons we get positively charged ions. So students, we can define metals as metals are the elements, or we can also define metals as metals are elements whose atoms can readily lose electrons So students, metals are the elements whose atoms can readily lose electrons, but here we have an exception which is hydrogen. So students, except hydrogen, as hydrogen also loses electron, but it is actually categorized into non-metals. So metals are the elements whose atoms readily lose electrons, and these form metallic bonds with the other metals and covalent bonds with the non-metals. So students, these are the elements whose atoms readily lose electrons and form metallic bond with other metals and ionic bond with non-metals. Students, most of the elements known to us are metals. Very famous examples of metals are like iron, copper, calcium, potassium, sodium, etc. Now students, the metals which are present in the earth crust are mainly, so the elements metals present in earth crust. Students, the most abundant metal which is present in the earth crust is aluminium. So the most abundant metal is aluminium, which is having symbol Al. And students, the percentage of aluminium in the earth crust is around 8%. So students, the most abundant metal in the earth crust is aluminium, followed by iron. So students, the next metal which is present in earth crust is iron, which is having the percentage around 5%. So students, these are the two most abundant metals present in the earth crust. First is aluminium, having percentage 8%, followed by iron with percentage 5%. So students, that means the metals are present in the earth crust. So let us study about the occurrence of metals. How metals occur? So let us study about the occurrence of metals. Students, metals are present both in the combined state as well as in the free state. First of all, let us know how they are present in the combined state. They are present both in the combined state also and in the free state. So first of all, which metals are present in the combined state? Students, the metals which are highly reactive, they are present in the combined state. So which metals are present in the combined state? Highly reactive metals. So these are highly reactive metals. Highly reactive metals are present in the combined state. So these metals are actually present in the form of the carbonates, nitrates, oxides, etc. Let us see an example. A very reactive metal is sodium. It is present in the combined state. So let us take the example of sodium. In the combined state, it is present in the form of sodium chloride. It is also present in the form of sodium nitrate. And students, even it is present in the form of sodium carbonate. So students, the metals which are present are highly reactive. They are present in the form of the combined state. And even the metals are present in the free state or the native state. So which are those metals? So the metals which are present in the free state, and students, free state is also known as native state. Students, the metals which are present in the free state are less reactive metals. So these are less reactive metals. Obviously, students, the metals which are less reactive, they won't combine with any other elements. So less reactive metals are present in the free state. We have very good examples are like gold, silver, platinum. Let us write the symbols of these also. Gold is having symbol AU, silver is having symbol AG, and students, the symbol of platinum is PT. So students, the metals which are less reactive, they are present in the free state, or that is known as native state. Moreover, students, there are metals which are present both in the combined state as well as in the native state. What are those elements? So, which are present both in the combined as well as in native state. So the examples of the metals which are present both in the combined as well as in the native state are like copper and silver. So the examples are copper, which is having symbol Cu, and silver, which is having symbol Ag. So I hope students it is clear to you how do metals occur. These occur in the combined state, native state, and there are certain metals which are present both in the combined as well as in the native state. Now students, the metals which are present in the combined state, these are actually present in the earth crust. And students, the Substance which carries the metal in the earth's crust, those are known as minerals. And students, there are certain minerals from which the metals can be profitably extracted. Those minerals are known as ores. So students, we can say all ores are minerals, but all minerals are not ores. So I hope students it is clear to you. Next we will study the physical properties of metals. Now students, let us study the physical properties of metals. Physical properties of metals. Students, the physical properties of metals is because of the metallic bond which it forms with the other atoms of the metal. Students, the reason behind the metallic bond lies in the structure of the atoms of the metals. If we try to break the atom into two parts, one part consists of the valence electrons. Valence electrons are the electrons which are present in the valence shell of the atom. So one part of the atom will consist of the valence electrons, and the leftover part of the atom, which consists of the nucleus and rest of the shells, is known as kernel. And students, in the atoms of the metals, these kernels are surrounded by the electrons, valence electrons, and vice versa. And the strong forces of attraction between the kernels and the valence electrons leads to the formation of strong metallic bonds between the atoms of the metals. So the reason behind the physical properties of metals lies in the strong metallic bonds. So students, first of all, let us study the physical properties. The first physical property we are going to study is the physical state. So what is the physical state of the metals? First is physical state. When we talk of the physical state of the metals, these are generally hard solids at the room temperature. So these are hard, solid at room temperature. The physical state of any substance is seen only at the room temperature. So the state which it possesses at the room temperature, that is the actual physical state of the substance. And at the room temperature, these are generally hard solids. Now students, let us study the examples of the metals which are hard solids. So what are the examples? We know, students, gold and silver are hard metals. So under the examples, we can take gold, which is having symbol AU, silver, which is having symbol AG, and etc. Now what is the reason behind the physical state of metals? What is the reason behind that metals are solids? What is the reason behind that metals are hard solids? The reason behind they being the hard solids is that their rigid packing in the crystals. The atoms of the metals are tightly or rigidly held in the crystal. So the reason is tight or rigid packing of the atoms So the reason behind they being hard solids is tight or rigid packing of the atoms of metals in the crystal. So when the atoms of the metals are tightly or rigidly held in the crystal, therefore they are hard solids. Now there are certain exceptions to this also. Let us see the exceptions. Though generally the metals are hard solids, but there are certain metals which are soft. So what are the exceptions? The metals like sodium, potassium, are soft Now, why the sodium and potassium metal is soft? The reason is that sodium and potassium possess only one valence electron. So as the number of valence electrons increases, the hardness of the metal also increases. One more exception is that generally the metals are solids, but there is only one metal which is in the liquid state at room temperature, and that metal is mercury. So another exception is that, one exception students, we have studied that sodium and potassium are soft, and one metal we know, that is mercury. The symbol of mercury is Hg. It is the only metal which is in the liquid state at room temperature, and mercury is liquid at room temperature. So I hope it is clear that what is the physical state of the metals. Generally the metals are hard solids with exceptions like sodium and potassium, and there is one exception to its state also, that though the metals are solids, but there is one metal which is in the liquid state at the room temperature, and that metal is mercury. I hope students the physical state is clear to you. Next, what is the melting point and boiling point of the metals? So second physical property is melting and boiling points. So second physical property is melting and boiling points. Generally metals possess high melting and boiling points. So metals have high melting and boiling points. Let us know the examples of the metals which have high melting and boiling point. Let us take one example now. Famous example is of beryllium. Beryllium is having symbol Be. Beryllium is having high melting and boiling point. Its melting point is around 1287 degrees Celsius. As you can clearly see here, this value is quite high, so it is having high melting point. What is the boiling point of beryllium? The boiling point of beryllium is also high, and it is around 2472 degrees Celsius. So students, I hope it is clear that metals generally have high melting and boiling point, and it is clear with the help of the example which I took is of beryllium. Beryllium is having high melting point of 1287 degrees Celsius and boiling point of 2472 degrees Celsius. So I hope students it is clear. Next, what is the reason behind the high melting and boiling points of metals? So what is the reason? The reason lies in their structure. Because of the rigid packing of the atoms in the crystals, the forces of attraction is quite high. Therefore, the melting and boiling point is also high. So the reason is rigid packing of atoms in the crystal results in high or strong forces of attraction. And students, the reason behind having high melting and boiling point is that the rigid packing of the atoms in the crystal result in strong forces of attraction. So that is the reason behind their high melting and boiling point. Do we have certain exceptions also? Yes, we have exceptions. Let us know about the exceptions now. Exceptions to high melting and boiling points are the soft metals, which are sodium and potassium. sodium, Na, potassium. Okay, so these are the metals which have low melting and boiling points. And there are two metals which are cesium and gallium. These are having that low melting point that even they melt on keeping on the palm of hand. So the two metals which are cesium is having symbol Cs, and gallium, these are having that low melting point that even if they get the heat from the palm of the hand, they melt. So these are the two metals which melt even on keeping on the palm of the hand. So I hope students, these two physical properties are clear to you. What about the physical state of the metals? What about the melting and boiling points of the metals? Let us discuss more physical properties.